Absolutely.
Okay, Julek, I think we can start.
Okay, YouTube broadcast is on.
Okay. Thank you so much. It's 12 o'clock here in Poland on the 17th of January 2023. Well, good morning, good afternoon, and good evening, wherever you are in the world. Welcome to this A+ lecture program, this A+ lecture event today or tonight. And I would like to introduce myself. My name is Marek Łukasik, and I'm Vice Rector for Development and Cooperation at Pomeranian University in Słupsk here in Poland. And I would like to welcome you to this special event today or tonight, as I said, because this is the last A+ lecture in this program. Let me just tell you something about the program, just in a few words. The A+ lecture program is a special program which aims at bringing high-class research to the society, because the A+ lectures is part of a wider program that we run here at Pomeranian University in Słupsk, which aims at bringing science, research, but also knowledge to the society. This is what we call the third mission of the university, so the public outreach. This is how we do things, and this is one of the examples. So A+ lecture is an important element of that, and let me tell you that this has been an honor to be the host, the initiator, in fact, and also the organizer of all of those A+ lectures that have taken place over the last 20 months. But I will get back to this short summary later on, because what is so important is that we have invited renowned guests to those A+ lectures, and many of them, all of them in fact, accepted our invitation. And today we also have a renowned guest from Lancaster University, because a friend of mine, a brilliant person, and well, a person who really changed my way of thinking in a way, is Professor Vaclav Brezina. And so hello, Vaclav, nice to have you here. I'm really glad that you accepted the invitation. Hi.
Hello, Marek.
I'm here. Okay, so I will just introduce Vaclav well in a second, but what I wanted to say, just being a little bit, maybe off the record, I think we've known each other for more or less 10 years, I think it will be. Yes, it's about 10 years.
It's been a while, yes.
And it's been a while, and it's because of the summer school organized at Lancaster University for summer school for corpus linguistics that really initiated this friendship. But also we have plenty of people joining us today here through the platform, but also through YouTube, who are part of this family, because I mean, this is how the networking worked. So this is how we connected, this is how we got together, and this is how people really are still a big family of corpus linguists, those interested in analyzing texts and analyzing those through specific pieces of software, but also statistics and so on. So talking about statistics, Vaclav, today, this is what we are going to do. But I will introduce Vaclav, because Vaclav Brezina is a professor in corpus linguistics at the Department of Linguistics and English Language, and a member of ESRC, Center for Corpus Approaches to Social Science at Lancaster University. So his research interests are in the area of applied linguistics, corpus design and methodology, as well as, well, statistics. That's the topic of today's lecture. He's the author of Statistics in Corpus Linguistics, Cambridge University Press 2018, and co-author of Fundamental Principles of Corpus Linguistics, CUP 2022, quite a new one, that's hot. He also designed a number of different tools for corpus analysis, and frankly speaking, I've known many people who have used them, such as Langsbox, BNC Lab, Langslex, and Lancaster Stats tools online. Vaclav, again, thank you for accepting this invitation. But before I give the floor to you, let me just point out to all those who connect through YouTube and those who are with us through the webinar platform that there are ways of asking questions. Now, there will be in a minute the question and answer box. That's where the chat is down there for those people who are connecting with us through ClickMeeting webinar platform. So that's where you can ask your questions, and those questions will be read out to you, and obviously Vaclav, time permitting, will answer those questions. All of those of you who joined us through YouTube, and I see plenty of you joining now, you can also leave your comment through the chat there. So you can use the YouTube chat and leave your comment there. And again, time permitting, we will read this out to you. That's the technicalities. The lecture will be available through YouTube later on, so it stays there. I'm so happy, Vaclav, that you're here with us, and I didn't really spoil it, so I didn't provide the title of the presentation, the talk, because the floor is yours, and this event is yours. The floor is yours. Thank you, Vaclav, again, and go ahead.
Thank you so much, Marek, and it's such a pleasure to be here with you and with our lovely audience out there, and many of us are connected through the Lancaster Summer Schools and other events. And I think, we share the friendship, and one thing that we have in common as well is our passion for linguistics and corpus linguistics in particular. And I would like to sort of draw on this type of experience also in this lecture. And the title is Learning from Experience. And this lecture introduces key concepts of statistical thinking for the humanities and the social science. And there will be plenty of examples that hopefully people can relate to. But the sort of core intuition I would like to base my lecture on is that statistics is not about number crunching. It's not about those complex equations that we see and read in textbooks. Statistics is about understanding the underlying principles that we share in common and our shared experience when we read texts and analyze corpora. So that's my starting point for this lecture. I also borrowed the definition and the title of the lecture from Edward Stafty's definition of corpus linguistics as learning from experience. So that's one of the possible definitions of statistics in general. I also provide two other definitions, one by Diggle and Chetwin, the classical definition of statistics that I'm drawing on as well, the science of collecting and interpreting data. Whenever you have data that you need to collect, be it linguistic data or any other types of data, metadata about our authors, for instance, their gender, their age, and all these interesting variables, as we call them, we need statistics to help us organize this data and interpret this data. And also offering my own definition as a discipline, which helps us make sense of quantitative data. So whenever we have numbers, we need to have some tools that help us organize these numbers and make sense of them. So that's my starting point. And the metaphor I'm using here is the metaphor learning from experience. And obviously, statistics gives us some specialized tools that help us structure this experience in a particular way and learn from it and infer things from it for our scientific as well as everyday practice. So the metaphor is this one. Learning from experience is a very human thing, and it probably also goes beyond the human experience into the animal world as well. The way we learned that we shouldn't touch fire when we sort of tried once, maybe tried once again, and then we've learned that touching fire is not a good idea. And these sort of basic moments of learning in our life, and then the sort of more abstract learning through the educational system, for instance, learning to read and write, learning numbers, and learning the basic operations with numbers. This creates our shared experience we can draw on. And when we look around, we can see many, many examples of this experience. And actually, statistics, that I would like to argue, is an everyday thing that is just formalized in certain areas, such as corpus linguistics or the digital humanities, and we can draw on these basic concepts and intuitions. So my overall message for this lecture is this. Statistics is part of our everyday lives. So let's learn from this and let's draw on this type of experience to learn about numbers and learn how to work with this quantitative information. If you want to have more details, and if you are interested in the underlying constructs and even the equations occasionally, I will refer you to the Corpus Statistics in Corpus Linguistics practical guidebook that has all the details, all the information about the concepts I will be discussing briefly in today's lecture. And there's much more detail if you are interested in that. But today's lecture will be focusing on the key underlying constructs that we need to understand in order to interpret linguistic and other types of reality that we have and share in our everyday experience. So just to give you an example, and as I said, I will give you examples for all these concepts that we will be learning together today. Obviously, we still have in our recent memory the shared experience of the COVID-19 pandemic, and over the course of 3 years, we've been exposed not only to the virus, but also to the data and reporting, the graphs such as the one that you can see in the slide here. And we've been exposed to new types of statistical information as well. And only in this single graph that you can see the cases in the UK and the development from March 2020 to April 2022, we can see a lot of things going on statistically here. We have time as our continuous variable on the x-axis. We have the peaks and troughs of the development of the pandemic. We also know that the early peaks and troughs are slightly underreported because we didn't have early in those days, we didn't have a reliable measure and ways of finding out the true development of the pandemic in the population. We have also something that is called a smoother, the 7-day average here, that is represented by the line. So we also deal with variation, individual random variation that we smooth in a particular way. So just in this single graph, and that symbolizes metaphorically our shared experience in the last 3 or so years through the development of the pandemic, and hopefully now coming out of the pandemic, we can learn some of the positive lessons from this, not only from the medical perspective, but also from the perspective of statistics in our everyday lives. So let's turn our attention to the linguistic reality, because this is what this lecture is really about. So statistics, first of all, helps us quantify linguistic reality. So whenever we have a text, a book, a newspaper article, such as in this particular case, I'm giving you an example of a newspaper article that appeared a few years ago in the Guardian newspaper about the New Zealand singer Lord. And whenever we have a text like that, or a collection of texts, such as a corpus, the British edition of Corpus 2014 being a very large collection of those texts, we can apply the same basic statistical thinking and quantify the reality. And all starts with counting. In this particular exercise, I'm asking the question of how many multi-word units can you identify in this short text? Obviously, this all depends on our understanding of what multi-word units are and how to reliably identify them in text. But imagine I have some operational definition of multi-word units, and I apply this to this text. I do some highlighting, as I did here in this example, and some basic counting, and I came up with a number. This number for this text in my definition of multi-word units is 16. And you can agree or disagree with that, that's absolutely fine, but we have a number we can start working with. And for this, we need some statistical tools to help us understand how this number relates to other numbers, perhaps numbers of multi-word units in other texts, in other genres and registers, in fiction as opposed to newspapers, for instance, in speech as opposed to writing, and so on and so forth. And when we start doing this, we have basic points of statistical comparison, and we can start talking specifically about linguistic reality through the lens of numbers, through the lens of quantification of a linguistic reality. So that's our first step. Before we apply any statistical tools, any statistical measures, we do some basic counting. We have to define our units, our constructs and our concepts, such as the multi-word units in this particular example. And then we can start working with the numbers that we get as a result of this simple process. So let me give you an example of 3 things at a very basic level what we can do with statistics, especially descriptive statistics. This is our entry point into statistics. So when we have numbers and we've arrived at the numbers through counting, the first thing we can do is we can generalize. So in this particular example, and hopefully you can relate to that, especially if you are interested in the humanities and the analysis of books and fiction in this particular case, you might be interested in the use of adjectives by fiction writers. Here I'm showing just a random sample of 11 fiction writers from the British National Corpus, and the relative frequencies per 10,000 words, so these are normalized frequencies for easy comparison across the different authors. And I've sorted them from the smallest frequency, relative frequency, to the largest. 508, 508 to 699 per 10,000 words in fiction. And the intuition behind this type of research might be that we might like to see how colorful the language is. Obviously, adjectives add that dimension of detail, especially in fiction, the dimension of description that is so important to create this register, this genre. So we might like to measure this across a sample of fiction writers. For demonstration purposes, I'm using a very tiny sample, just 11 authors, but there will be hundreds of them if we apply this on a larger scale to corpora such as the British National Corpus 2014. So how do I make sense of these numbers? I have a line of numbers, I can go on, but just mere listing of these numbers doesn't help me very much understand what is going on with adjectives in fiction writers. Is there a way to generalize over this potentially very long line of numbers, which might be far too long to list them in a report? Well, I can use one single number that will represent the whole range of numbers here in this data series. In this case, I can take one number from the middle of this ordered line of numbers, and this number in statistical terms is called the median, the middle value, when we have all our values ordered from the smallest to the largest. And this single number can be used in statistical terms as a measure of central tendency to represent the whole range of these numbers. However, median is only one way of approaching this. It is a type of average that we can use in the data set. We can also, and you've been doing this probably very often in your everyday type of experience and also your academic scientific experience, there's another type of average, the arithmetic average called the mean. And this value is calculated by taking all these numbers, adding them together and dividing all by the number of cases or observations, in this case 11. So the mean value for these numbers is 591.45. So another way of approaching the central tendency in this line of numbers. What we also want to be doing, in addition to accounting for the central tendency in this line of numbers, is to account for variation, because we know that variation is part of our everyday experience. We all are unique. We all use language in a slightly different way, and authors do the same. So how do we account for this variation so that we don't have just one number, but we also have some sense of how spread out the data is in our data set? So when we think about the median as our model for this data, the one number that represents the whole range of numbers, we can use a simple range value. So we can say the middle value, the median, is 567, and the range is between 699 to 508, which is 199 when we just subtract the numbers. So the range would be 191 as a value. So we now have two values that represent the data set quite well. Often, because the values at the end of the distribution can be extreme values, or sometimes we call them outliers. In this particular case, it's not such a big deal, but in real life, many of the values at the end of a distribution are quite extreme, either too low or too high, and do not represent the central tendency of that distribution. Instead of range, we can look at something called an interquartile range that I'm displaying here again with the same data set. The interquartile range is much more stable than the range itself, gives us an additional point of information about the variation when we have the median in the middle and the 50% of the central values in this interquartile range. In this particular case, the value is 104. So already we are dealing with statistical concepts that help us make sense of this data, of the variation. We mentioned also the mean as a value, and I'm quoting it here again. If we use the mean as our measure of central tendency, it is common to use another measure of variation called standard deviation. Again, there's a bit of sort of a statistical trick there, how to compute that. The equation is a square root of sum of squared distances from the mean divided by the number of cases, in this case 11 minus 1, so divided by 10, which gives us the value of 63.8. Again, gives us the sense of variation in the data when we look at the mean, which is 591.45. So these are different ways of describing the data and getting at what's important about the data. What's the general picture? What's the gist of the data? And these are different types of answers from different angles, depending on what you are trying to achieve. Another thing that we can do with statistics is to find relationship. So let's keep the first line of numbers as you've seen that in the previous example. But in example 2, I'm adding another line of numbers below that. So I'm interested in the use of adjectives plus verbs, that's the second line, by fiction writers in the sample of 11 writers in the British National Corpus. So again, I have these numbers here, but instead of one value, such as the mean or the median, in this case, I will give you a visual representation of this relationship. So you might be asking the question, if the authors use many adjectives, do they also use a lot of verbs? Or, is there any sort of relationship between these two grammatical categories? The answer to that will be this line, and I will give you some more context for this line in a moment. This line shows a negative correlation, relationship that is inversely proportional. So the more adjectives the authors use, the fewer the verbs, and vice versa. So I'm give you the full picture here. This line comes from a graph that is called a scatter plot, and this is the line that runs through the middle of the data scatter, the data cloud that we call the line of the best fit, or the regression line. The individual circles in this graph are the individual authors that we have in our sample. On the x-axis, we have the frequencies of adjectives, also normalized, and frequencies of verbs, normalized, so that we can compare like with like. And in this case, we can see this very strong relationship that tells us something very important about this register, the register of fiction. There's a competition, basically, between verbs and adjectives. So some authors and some texts are much more descriptive and use many more adjectives, but they don't have the dynamic elements, the verbs in them. So there's a sort of almost a competition between description and action in fiction writing. And we can then sort of look at the examples of those texts and see what is really happening there. So the statistical technique, in this case, the statistical visualization, helped us understand this essential relationship in the data by visualizing these numbers that otherwise wouldn't be that easy to interpret. But once you see the line, you can see immediately what's happening in the data. What we can do, and this is the next step, and this is sort of now becoming slightly more advanced for those of you who want to go beyond this simple visualization, we can also write an equation for this line. And maybe from secondary school or from the university, you might remember what an equation for a line looks like. And we can represent any line like that, any linear relationship, by an equation that has the format of y equals a, that's a number, plus b, another number, x. When you apply this to this data set, and there's a particular technique that we can use, I won't bore you with the details, but it's a technique of least squares that we get to where the line should go in our data set. We get an equation that is particular and specific to this example, the use of adjectives and verbs. So this equation, y equals 2,676 plus minus 0.96 times x. This equation helps us express the relationship between the use of adjectives we would plug in under x, and the use of verbs we would get as a result of this equation for the verbs. So the y is the verbs that we would like to know, and the x is the adjectives that we measure. So what this equation says is that if our model, the model based on this data set, is correct, we should be able to predict the relationship and the number of verbs in any fiction text outside of this sample. So let's test this empirically, whether this is truly a useful model. So what I'm going to do now is I'm going to take a book that wasn't among these authors. It wasn't among these 11 texts that I used to create this model, but I will test the model whether it really helps us predict the number of verbs based on the number of adjectives. So here's the book, Terry Pratchett. Some of you might know this book, The Dodger. And you can take any of the books you like in English and try whether this model would work for that particular one. And we use the same equation. We count the number of adjectives in Terry Pratchett's Dodger, and the number is 580. And using the equation, we are going to predict the number of verbs. And the predicted number of verbs based on the equation is 2,119. So is it a good prediction? How would we find out? Well, we can use corpus linguistic techniques to go and count the number of verbs in the book. And when we do this, we get a number, the real number of verbs, as 2,182. So pretty close to our prediction. The model is never a perfect representation of the reality, but helps us make some useful predictions about reality, as we did in this particular case, based on stylometry, stylistics, and use of corpus techniques. So we were pretty close to the reality, and we can see that this equation, this simple equation for this linear relationship between verbs and adjectives in fiction text can actually reveal something interesting about this relationship and is applicable beyond our sample, which is very interesting. So my first message based on these examples is that statistics helps us quantify linguistic reality in this particular way. We looked at how to generalize, how to find relationship, and how to go beyond that type of data. Another thing I would like to talk about is, and now we are moving into the territory that is called inferential statistics. So far, we've been looking at descriptions and largely describing what we saw in the sample, although in the last example, applying this to another text would be sort of going beyond the sample and reaching out to the population, creating models that work not only for the sample, but for the population. So that was our segue to another area of statistics that is called inferential statistics. And there are two crucial concepts in inferential statistics, and that's the concept of a sample and the population. And again, you might like to think about the question that I'm displaying here in this slide. What is the difference between a sample and the population, and how are these related, and how can they be related statistically? So again, going back and drawing on our everyday experience, the experience that I would like to draw on is the experience of sampling something. And in this case, let's take an example such as wine tasting. The principle of wine tasting is very simple. Someone opens a bottle and gives you a tiny, tiny sample to taste, to appreciate the quality of the wine. And they give you another sample of another type of wine, and so on and so forth. And you go through that and actually experience in one afternoon, evening, the different types of wine and the quality of different types of wine without you actually drinking all the bottles that were there. You take just a tiny, tiny sample. And obviously for practical reasons as well. I think after that bottle, you wouldn't be able to appreciate any quality of the wine. So the sample is actually really important, even in this exercise of wine tasting. And we also, for practical reasons, use similar logic in inferential statistics. So let's see how this works. So corpus in corpus linguistics is a sample of the reality. In this slide, the metaphor is that the color, the different shades of the color, are different uses of language, spoken and written, and newspapers and fiction texts and online language, and all sorts of variation that we can think of. So there's a sort of a line of variation across different dimensions that are represented by the different colors in this slide. We start with a sample, sort of an empty container, and we want to go to different corners of the language and try to get a bit of each of these uses, so that ideally at the end of this process you would have something like that. So the sample, which is much smaller than the population or uses of language out there, would reflect, however, in some essential characteristics the population. In this case, it is symbolized by the matching color and the matching shades of color in the sample and in the population. And therefore, based on the sample, where we have just access to the sample, which is much more manageable because we have the 11 texts rather than thousands and millions and billions and trillions of texts, we can actually say something useful about the population. Think back to the metaphor of wine tasting. You don't need to drink the whole bottle to be able to appreciate the quality of the wine if you just have a tiny, tiny sip in your sample. So what we are doing, and the process of doing this, is called inferential statistics. We are inferring something based on the sample about the population, the uses of language out there based on our sample, based on our corpus in the context of corpus linguistics in particular. So this is what is happening in the background, and the procedure that we are using, the statistical procedure that enables us to make those inferences, is called the null hypothesis significance testing. This is the sort of most famous and most visible sign of statistics, and you've probably encountered that in the form of p-values. When you read an academic article, you see p equals and there's a particular number, and this is being reported. Or confidence intervals. This is another way of expressing the same idea. So this is really probably the most visible side of statistics in social scientific research and in the research of the humanities, where you actually use the null hypothesis significance testing and report it in your reports if you have a quantitative type of study. So let me give you an example here. I'm using a sociolinguistic hypothesis. Men and women use language differently, and there's been a lot of talk about this and how the language differs across genders, and can we actually measure that? And we can look at the use of different variables, use of swear words. Do men swear more than women? Hedges, do women hedge more than men? And all these sort of things that have been hypothesized. So we can operationalize this hypothesis even further to look at the specific features we might like to search in our data. The next step that we will need to do is to formulate what is called a null hypothesis. The null hypothesis will tell us the reverse of our hypothesis that we want to actually test using the process. So there is no difference between how men and women use the language. And for technical reasons and the reasons the logic of this procedure operates, we are going to look for the evidence in our data against the null hypothesis. So I'll take you through the process step by step, because this is a process that is common to all statistical tests, no matter what they are. And the logic, the underlying logic, is the same. So we now have our hypothesis, our null hypothesis. And what we are going to do now is we are going to collect some evidence, or look for the evidence that is available in existing corpora. So imagine I have two corpora, the corpus of male speech and corpus of female speech. I'll do the counting, let's say counting of swear words, and I get two numbers, 16 and 14. The corpora are our samples of language, but what I would like to know is whether there's real difference between the male and female speech in the population, in how people use language out there. So is this difference due to chance, or is it statistically significant, is my question. Because when I take samples of the population, there's something called a sampling error. So I want to see whether this difference is strong enough and robust enough so that I can draw something important about the population. So what I do is I will look at the question, and this is a rephrasing of the previous question: how much evidence do we have in the data to reject the null hypothesis? Null hypothesis, I will apply a particular statistical test depending on the type of data I'm looking at, the shape of the data set. And again, I would refer you to the 2018 book if you want to know all about different data sets and different research designs. And the statistical test will be determined by the design of your particular study, what sort of data you have, categorical, or is it continuous data, and so on and so forth. But no matter what the statistical test is, you will get one value out of that, and the value is p-value. And you can now think back to your classes of mathematics and statistics and think about whether you would be able to define the p-value. We see it everywhere, but not many people are actually able to provide an accurate definition of what a p-value is. So you can take just a small moment to think about what a p-value is in this context. The technical definition of a p-value is the value of probability, so that's why p. The probability of seeing values at least as extreme as observed if the null hypothesis were true. So if the difference was purely by chance. Right, so seeing 14 and 16, or even more extreme values, even more difference, 13 and 17, or even more, if this were due to chance alone, if the null hypothesis were true. There was no true difference between male and female speakers. So you get the value, and you can get two situations here, really. In the humanities and social science, we usually use the conventional, and this purely conventional threshold of 0.05 or 5% as our cutoff point for the p-value. So if the p-value is smaller than 0.05, the probability of seeing these values only due to chance and statistical sampling error is low. So if it's smaller than 5%, we are happy by convention to reject the null hypothesis and say that this result is statistically significant. So we have enough evidence in the data to reject the null hypothesis, and we can say that the difference between male and female speakers is statistically significant based on the data that we used. However, if the p-value is larger than 0.5, then we just have to conclude that there's not enough evidence to reject the null hypothesis. Maybe we need more data, or maybe the difference is really not there in the population, but we don't know. We can't accept the null hypothesis because in the logic of the null hypothesis significance testing, this is not possible. So we can't draw any firm conclusions based on large p-values, but we can't reject the null hypothesis in that case. As I said, the null hypothesis significance testing, either in the form of p-values or in the form of confidence intervals, that are very popular these days and are actually more subtle and useful ways of giving us an idea about where the particular value is likely to lie in the population. We can use this across the humanities and social sciences in the analysis of register variation, for instance, where we are looking at correlations, factor analyses, authorship investigations, again, correlations, t-tests, sociolinguistic studies, and where we have Mann-Whitney U-tests, ANOVAs, t-tests, and so on and so forth. So this is a variety of statistical tests and measures that we can apply in a variety of contexts, but the underlying assumptions and the underlying procedure and philosophy of null hypothesis significance testing is the same. So our second message is that statistics helps us test hypotheses. And that was the other crucial thing that we talked about today, the inferential statistics and what lies behind it. The final thing I would like to draw your attention to is symbolized by this graph. And I'm just wondering whether anyone would have an idea about what this graph might represent, what this graph is about, whether anyone can make any sense of this graph at all. It is supposed to be a map, and you might see, a bit of the map of the world, a bit of Greenland at the top, and there is some kind of relationship. This is a network that displays the relationships between different parts and places on the planet. However, the graph is not very successful one because it's very hard to interpret what is going on there. So it is an overpopulated graph, an extreme example of an overpopulated graph, a graph that loses the communicative value, although the underlying data is there. We just lost the ability to interpret what is going on there. So not all graphs are successful graphs, and this is the third intuition I would like to draw on towards the end of my lecture today, and give you some tools to be able to evaluate good statistical visualization from mediocre and not so successful one. There's an English saying a picture is worth 1,000 words, and I'm really posing this as a question. Is a picture that we use for statistical purposes, so a graph, chart, worth 1,000 words? Does it really communicate a lot of information? And this is the critical question that we should be asking when we think about data visualization. Again, I'm including here reference to a recent chapter from the Routledge Handbook of Statistics of Scientific Communication, Statistics and Data Visualization. So if you want to read more about the visualization aspects of statistics, I would point you to this chapter. There's also a lovely historical overview that you can read about the development of scientific visualization across ages. So what is the core principle of statistical visualization? The core principle is focus on the data. What we want to see in the graphs, as opposed to images and pictures that we want to see in art galleries that are used for aesthetic purposes. In scientific visualization, we primarily want to see data. It's all about data. And there's a way to measure this. And the way to measure this is called the data-inc ratio. And this is a basic equation for the data-inc ratio. And the metaphor is, again, very simple. Imagine a printer that you have connected to your computer and you want to print some graphic. You use certain amount of ink to print this graphic, and you can actually consider how much of that ink was used to display data in the graphic and how much of the ink was used to display everything else, all the frills and all the colors for aesthetic purposes only. So again, I would like to demonstrate this with a simple example. So here I have a graph that I produced in Microsoft Excel, and Microsoft Excel is very intuitive and helps us produce graphs very, very quickly. But sometimes there's a temptation to overdo these graphs with all those graphical frills that the tool offers us as well. So imagine that this is a graph that I'm going to print on a page, on an A4 page, and the size of the graph is 10 centimeters by 10 centimeters, just for the purposes of our illustration, to be able to do some counting and some measuring. This is a graph that on the x-axis displays the number of the definite articles used in texts, or spoken data in this particular case, and the number of the first person pronoun I's is displayed on the y-axis in this scatter plot. The dots inside the scatter plot are the individual speakers, and again we have the line of the best fit going through that data cloud. So you are familiar with this type of graph, but this is a particular type of rendition of the scatter plot. If we just plug in the numbers into the equation, and first of all, we might also note that there's a bit of redundancy already here. We have the title at the top, but we also have the caption of the figure at the bottom, basically saying the same thing. So we are not using the space very economically. We are not using the space that well, already just looking at these type of redundancies. But when we are focusing on calculating the data inc ratio, we can plug this into the equation I showed at the beginning in the previous slide, and we can get a number, such as a number for this graph, which is 0.16. The data inc ratio is a measure that ranges from 0, very poor type of graphic visualization for scientific purposes, and 1, which is very efficient visualization. So this one is very close to 0. And as you can see, there's a lot of redundancy. There's a lot of ink wasted, if you like, that is not used to print the data. So what is the alternative that we have in this particular case? Well, this is the rendition of the same data set, but hopefully more successful. I use the Lancaster Stats tools online to produce this graph, as opposed to Microsoft Excel that I used to produce the first graph. In this case, I've added some more information to the graph to make it informationally richer. So we have the same data points, but they also have some labels. The labels have some indices, the numbers that identify individual speakers, but they have also the F or M. F stands for a female speaker, M stands for a male speaker. So by looking just at the points in the scatter plot, I can already see the gender, the sociolinguistic variable of these speakers immediately, and I can be thinking about gender differences already. I also got rid of some of the redundancies from the previous graph, and importantly, I got rid of the color background that wasn't important to communicate the data, but only muddied the waters. When I run my numbers here for the data inc ratio, I get something very close to 1, so 0.93, and that shows how efficient this data visualization is compared to the previous one. So this just demonstrates the core message. Focus on the data, focus on what is important for us to know for statistical purposes. So the message here is make sure a picture is worth 1,000 words. Make sure that we really use the space on the page usefully, and make sure that visualization really speaks and shows us the relationships in the data, not like the early example of the network that was far too complex for us to be able to interpret it efficiently. So just in conclusion, because I'm drawing to the end of this lecture, I would like to say that from my perspective, statistics is not about number crunching and solving equations. So this is an image of what statistics is not about. And some people, especially in the humanities, are worried that they would have to learn all these very complex processes in order to be able to use statistics efficiently, and that's why very often they go nowhere near statistics and quantitative information, which in my opinion is a pity, because if you realize the simple fact that computers are much better at dealing with equations such as this one. And we have tools such as Lancaster Status online. If you scan the QR code, you should be able to see and go there. It's a free tool that allows you to run different types of data analysis and visualization and effective types of visualization that I demonstrated in the previous examples very easily. So you copy paste the data, click a button, and you get the answer. So the computer does the hard work for you. However, what you need to understand are the underlying principles. And some of these I was trying to highlight in my lecture today. So what I would like to finish by is to just say what is crucial here is to understand the data and how it operates and what is the key underlying principles in the data. So I'll stop here and hopefully we can have some discussion about this, what is interesting from your particular perspective in your particular context. So thank you so much for listening to the lecture.
Thank you so much, Vaclav. I'm really happy that this this has taken this form, and we have plenty of people who have joined us. And let me just say that I see some positive feedback already coming in, Vaclav. So thank you so much for the lecture. And well, I mean, also text messages coming in to my own mobile phone. So thank you so much. It was really insightful, especially as it's an important element of an introduction to seeing the world in a different way. So statistically, but also through corpus linguistics, I mean, using corpus linguistics data, but also going beyond. So I appreciate it so much because I mean, we very often think about statistics in a very mathematical way. So thinking that all of those very difficult equations have to be memorized, and probably also this is what makes most people really afraid of, really, or being haunted even by those equations in mathematics, well, this prevents them from tackling statistics at all. So I'm really happy that this lecture in this form has taken part and place, excuse me, and then you agreed to take part in this lecture. Thank you so much. Now, there is this new feature that we would like to test with you, and this is the so-called question and answer session. And you see where the chat box is, you see those you see a little tab there which says the question and answer mode, so you can click there and also ask questions through the that box. And this all of those questions or most of those questions will be displayed as you can see them now. So Vaclav, the first question here is, can you tell us where you can find the information on the equation? I mean, that was the equation for a line, I think. That was the equation for a line. Yes.
Yeah, absolutely. There was the very powerful line that helped us predict the relationship between the use of adjectives and verbs, and it was based on that sample. As I said, the line itself is called sometimes the line of the best fit or the regression line. So this points you actually where this line is coming from. So when you have a data cloud, you want to find a way to fit a line through the data cloud. So all the data points are as close as possible to the line, because the data points will never lie exactly on the line. They will be scattered around, but we want to make sure that the line goes through the middle of the data cloud. The way to do this is to use a regression model, use a statistical tool that can compute those regression models. Lancaster Status online is one of them, but any statistical tool such as the R or SPSS, whatever you are familiar with, can compute these simple models. StatsTools Online will also give you the form of the equation that is there to that underlies these models, and there might be some online calculators as well. So if you go for calculators of regression lines or something like that, you would be able to do that. The technique is a technique that is called the method of least squares. So you are computing the squares that from the individual point to the possible line. So there's a technique of doing that. So there's a sort of statistical procedure that is fairly complex. So I wouldn't do this manually. But it is a very simple, straightforward procedure for any statistical calculator, any statistical tool to obtain this, because you have to figure out where the line needs to go. The equation for the line then is very simple. As you can see, it's sort of b plus a times x. So the equation, the result itself, is very, very, very straightforward and very straightforward to apply. But if you have multiple different points, especially, I used 11 examples, but you might have, 100, 1,000 points. So at that point, you really need the power of a computer to tell you where the line should go through the data set, if that makes sense.
Okay, thank you so much, Vaclav. And that was the question from Alessandra. So thank you. But we have another question now, and this question is comes through YouTube. Let me read it from Magdalena. Which particular statistical test to choose to interpret your data seems the most challenging part? Does your book offer detailed advice? Oh, that's what you did as well. Thank you so much.
Yeah, that's a great question, and I think it really reflects on the general experience that people have. Because one of the most frequently asked questions I get is, what statistical test should I use in my particular context? The book provides, I think, a lot of guidance in this regard. It might not have all the answers you would like to see, but it goes through the topics that people commonly investigate in corpus linguistics, giving also some specific examples and mini studies where people can actually see the type of tests that are suitable for a particular type of data. And this really sort of answers the question. The test really depends on the shape of your data and on the research design that you have. Questions such as, what is the case? What is the observation in your data set? Are you measuring the numbers in individual texts, individual speakers? Or are you looking at corpora in broad terms? So you have the sort of whole corpus design or individual speakers design. Or are you focusing on a particular linguistic feature that has some variance, such as the use of active versus passive construction, and that's the focus of your data. So you have all the passive and active constructions in your data set, and then you're sort of measuring what are the parameters, what are the predictors, the variables that help you predict whether a passive or active construction appears in the data. There will be a specific linguistic feature design. So depending on this, you will get the answer. And obviously, if a statistician looks at your data set, if you send them the Excel spreadsheet, they would be able to tell you immediately what sort of statistical tests would be useful in that. But if you have the patience and go through the book and look at the similar types of analyses that you are interested in, and just jump into the particular chapter, I think you should be able to get the answers that you are looking for.
All right, so thank you so much, Vaclav. There are also many warm words coming in, like many words of gratitude and many thanks from Natalia, Anish, and I think others are also posting at the moment because I can see that. But we have another question. So that's the question you can see. Could you please answer this?
Yeah, the Bayesian statistics.
Yes, it comes from Tomek, please. Mm-hmm.
So why is Bayesian statistics not used that frequently in corpus linguistics? Although there's a paper by Andrew Wilson that actually discusses Bayesian statistics from the perspective of a corpus linguist, from the perspective of a corpus background. But I fully agree with your premise that we don't see much of the Bayesian statistics. And I think the reason for this is that corpus linguistics is still a relatively new discipline. So whereas physics and biology and the natural sciences, chemistry, had epidemiology, had long time to develop the procedures and look at the appropriate types of statistical techniques. Corpus linguistics, I think, is at an exciting moment of discovering different possibilities and looking at what the limitations are of the current approaches, and also looking at the alternatives, and Bayesian statistics might be one of the alternatives. I never believe that there's one tool fits all type of answer in any area of science or any area of human life. So where Bayesian statistics can be helpful is to sort of predict things within the context when we are looking at predictions and the broad modeling, because the Bayesian theorem is very, very important and very easily to implement in these. Null hypothesis significance testing is also something that has been used quite widely, but not always successfully. And there's a huge debate about whether the p-values are not over-interpreted and whether we should be looking more at quantifying things in a different way, also within the traditional statistics. So not only going straight to Bayesian statistics, but also thinking about meta-analyses. Meta-analyses are really, really important in many areas, and in corpus linguistics and in digital humanities, I think they will become even more important. So I would see the sort of move slowly towards estimation rather than p-values, and this is within the null hypothesis significance testing paradigm. So effect size reporting on the confidence intervals around the effect sizes, which gives the field the ability to then statistically combine the data. So we were talking about learning from experience, and this can be an individual journey, but as a field, we can also learn from our common experience. And one of the statistical tools for doing this is meta-analysis, still within the sort of traditional statistical thinking that corpus linguistics is still to properly adopt. So I think there are many exciting ways, and Bayesian statistics can be one of the pathways that corpus linguists might like to explore.
Okay, thank you, Vaclav. Thank you. There is another question coming in through YouTube, so I don't know if it's possible to display this now. Maybe I will read it out. Maybe Julek will be able to put it on the screen. Thank you. If we use p-value to measure relationship between two language units and get the p equaling 0.055, can we possibly predict the relationship between the units at lower level of significance, or must reject it?
Brilliant question. And if the p-value is very close to the cutoff point, what do we do? In the null hypothesis significance testing, in this sort of classical process, we have to set the p-value at an early point. So we have to, before we look at the data, we should decide on the threshold, because what is really tricky in science is trying to tweak the data so that it supports our hypothesis. So to prevent this, we always, in any type of experiment, will set the p-values at an early level. So, in medical science, the p-values are often 0.01 or even smaller, because obviously the importance and the evaluation of the risk of spurious results, which obviously would have much more severe consequences than in stylistic studies, for instance, when you think about that. So that's one of the things. So in this case, because you know, if you want to have a sort of a nice, straightforward study, I wouldn't play with the p-values when you look at the data. I think it would be the wrong type of approach to do that. It indicates that, you know, perhaps if you collect a bit more data, the p-value would be lower and below the threshold, below the cutoff point. So I think you know, the possible response, if you just want to go down the p-value route, would be just to collect a bit more data. And if the patterns are consistent with a bit more data, you would get certainly a statistically significant result based on that. Another approach to that is an approach that I already briefly mentioned. I didn't have space for in the lecture to explore that, but there's a approach that looks away from the p-values and reports effect sizes and confidence intervals. And they are not one point where you would say statistically significant or not, but they give you the whole confidence interval around any statistical value, which can be reported nicely and can be then combined with other studies that bring similar type of experience, and they can then add these in meta-analyses to actually strengthen this beyond statistical chance. So I think that would be the right type of approach to think about the model. I wouldn't, you know, necessarily change the p-values in the middle just because it is close to the significance, because it is like, you know, you've made a commitment to a particular alpha level, and we just have to sort of stick to that. Otherwise, we are changing our methods to suit our hypotheses.
Okay, thank you, Vaclav. And I can see another question from Alessandra, which basically is a very kind of less technical, but more important in the from the educational perspective and in the educational context. So based on your experience, how do humanities students react to statistics? And what piece of advice would you give for the effective teaching of statistics in this area?
Absolutely, and I think this is a crucial question, and something that is very close to my heart, the question of statistical literacy, being able to, not only at the university level, but throughout the educational process at secondary schools and primary schools, being able to introduce students to quantitative information so that they are able to interpret quantitative information in newspaper reporting, for instance, not only academic writing, but in sort of everyday life. Because statistics, in my opinion, in this area is also very much connected to critical thinking and these transferable skills that we as educators should promote. But based on my experience, you know, many times when you talk to students in the humanities, in linguistics, and you ask them, why did you choose that particular subject, history or literary studies or linguistics, you know, the straightforward answer is because they hate maths and they just didn't enjoy it at secondary schools. When you talk to university students, undergrad students here at Lancaster at least. And I think it speaks volumes about the way we approach the education in statistical literacy. And I think my advice would be to really take a step back, think about how statistics connects to our everyday experience, how the basic experience of counting things and working with numbers connects to what we are doing already. And people are very often surprised, and that was actually, you know, the motivation for my lecture today. People are often surprised how straightforward the statistical thinking is if you present this based on the shared experience that we have. But there's so much work to be done in this area, and I would encourage you and any educators to try to find ways, and it is a trial error type of journey in my experience. Try to find different ways to approach this, and the basic message from me is that statistics and mathematics is really not about the number crunching, because we can delegate that very, very easily to the computers nowadays. Everyone has more computational power in their mobile device than any computers had even sort of 10 years ago. So we have the computational power to do all these things, but we need to find accessible ways to demonstrate to people that there's no magic or black magic behind statistics, but everything is really very common sense.
Okay, thank you, Vaclav. I think we have two more questions, but I think we will be wrapping it up. So maybe two questions very quickly, two of those coming in through YouTube. The first one reads, does the formula, so the verb adjectives, work with the book, say verb and its translation adjectives?
That's an interesting one. The formula was presented as an example based on a very tiny sample. So it was a sort of pedagogical tool. I think generally there's a very clear relationship, the sort of negative correlation between verbs and adjectives. So you would see that certainly in fiction, and it's an empirical question whether we can go beyond that, and whether when we look at translation, how this works. So I wouldn't like to overstate my case, because the formula was based on the 11 randomly sampled authors from the BNC. If you have a larger data set, and we have now thousands of texts in the British National Corpus 2014, for instance, you would be able to have a more precise formula. I don't think the picture will change much, but it will help you make a more precise prediction. And we might also bring in some other aspects as well. Maybe there's an effect of the age of the authors, or the subgenre. Fiction is a very broad type of genre, so maybe crime fiction opposed to other types of fiction would use language differently. So we might need sort of more data, more variables to be more precise, to have more confidence in that formula. But I would say, broadly speaking, try it out, see whether that holds water. And obviously, for serious published research, you would need to have a larger sample to be able to, say with more confidence and with more precision what the relationship would actually look like.
Okay, thank you so much. And that question was from Natalia. And I think this will be our last question today, because we'll be wrapping it up, as I said. This comes from Samri. It comes from, and obviously it's from YouTube as well, as I said before. In stats, in corpus linguistics, we're almost always talking about the effect of fixed effect predictors. Why do linguists ignore explaining the random effects parts in order to explain the research question?
Yeah, obviously, this is sort of an advanced thing for, people who are not familiar with this type of approach. This is an approach that is very often used in mixed effect models that help us look at linguistic variation, and just to explain the question for those of you who might not be familiar with this type of modeling. The fixed effects would be the effects of gender, for instance, the effects of age, whereas the random effects might be the effects of the individual speakers. And we can sort of account for this type of variation as well in linguistics. And we know that this is so important to be able to have the sort of full picture of what is going on. I think it is a useful tool, and I wouldn't doubt that at all. There are some studies that use the mixed effect models in corpus linguistics. So to be fair, we already see some examples of this being used in the field. But again, I would think about that as a tool. So you don't always need very complex statistical modeling to answer all research questions. So sometimes you need a screwdriver, sometimes you need a hammer, and sometimes your hands are good enough to do things. So I think it is a useful addition to the toolbox. Certainly something that we should be thinking about. But I wouldn't say everyone should be doing this, because I think that wouldn't be very helpful. And sometimes even simpler approaches that just describe the reality and going back to understanding descriptive statistics properly can help us do the job. So it really depends on your data, would be my response. But that's a brilliant point.
Okay, thank you so much for all of your questions. So we will close the Q&A session now. Thank you, Bart, for your answers to those questions. Very insightful and good questions and brilliant answers. Thank you. I would like to just go ahead with the one last element, which will be, Ulek, if you can help me, I would like to find my own little, yes, a few slides more, because I would like to summarize the whole program. I would like to, well, just say thank you, because this was the very last A+ lectures ever within the Active University program. We held 15 meetings like this one over the period of 20 months. And we had plenty of experts, a number of experts who were really renowned experts in their fields, coming from, as you can see, renowned and very famous, so to speak, universities around the world. So we are really grateful to all of you who have taken part in the A+ lectures, who accepted our invitations, but also participated in A+ lectures as listeners and be taking active part, obviously, in our question and answer sessions, basically trying to learn as much as you can. Just to remind you, this program, so the Active University program, is part of our outreach program. So this is our way of getting or bringing science, bringing research to the society, but also to be more international, for the university, for Pomeranian University in Słupsk to become more international, to be able to host our guests, to create links, to network. So this is the means. This was the means to doing it at our university. I would like to remind you that those 15 A+ lectures are available through our YouTube channel. So if you go and have a look at our YouTube channel, you will find the A+ lectures, all of those A+ lectures recorded. Some of those